This is Geometry, Unit 5, Day 2. We're talking about properties of parallelograms. We're going to talk about what a parallelogram is first. So up on top here, we have parallelogram. Parallelogram is a quadrilateral with two sets of parallel sides. So when we talk about what a parallelogram is, that's all that we can refer back to. But now we're going to come up with these different theorems, and these different theorems are going to go a little bit more in depth about if you have a parallelogram, then you could also have other things. So this first one, a quadrilateral is a parallelogram, then its opposite sides are congruent. If you have a parallelogram and your sides are parallel to each other, regardless of how you move it around, it is going to stay parallel to each other, and the opposite sides are going to stay the same length. So here I've constructed a parallelogram, and as we move it around, the sides stay parallel to each other all the time, and the side lengths are also the same length all the time. The opposite sides are the same length. So looking at our figure, RS is going to be congruent to QP. QR is going to be congruent to PS. The opposite sides are congruent. If we look at our parallelogram, notice that the opposite sides, the ones across from each other, not next to, but across from each other, those are both the same size. So you look here and we have an obtuse angle. On this side we have an acute and acute. If we adjust them, as the acute is getting bigger, bigger, and bigger, so is its opposite side. So they stay the same all the time. If they're acute on opposite sides and they start to adjust, they adjust at the same amount. So we're going to recognize that opposite angles are always congruent. P is congruent to R, and Q is congruent to angle S. So when we do these problems and we solve for X and Y, we're going to also write out the equation to solve it, and we're also going to state what the theorem is. So if I'm going to solve for X, I'm noticing that X plus 6 is on FG and 13 is on JH. These are opposite sides. I've heard about how opposite sides are congruent if it's a parallelogram. I do know this is a parallelogram because of the arrows. The double arrows tell me that those two sides are parallel, and the single arrows tell me that those two sides are parallel. So I have two sets of parallel sides. So I'm going to say if parallelogram, then opposite sides congruent. So I know that FG is going to be congruent to JH, which makes X plus 6 equal 13. Subtract the 6 across, and we get X is 7. Now I'm looking at Y. What's the value of Y? Well, I notice that y and the 68 are across from each other. Those are called opposite angles. So I've heard that if you have a parallelogram, then opposite angles congruent. So if we have angle H, and we know that it's going to be congruent to angle F. So y is going to be equal to 68. Notice how I wrote down, and I know what the theorem is that helped me write my equation. I didn't just give an answer, I supported it with information. Here's another theorem. If a quadrilateral is a parallelogram, then its consecutive angles are blank. Well, if we take our parallelogram back, consecutive angles are the ones that are next to each other. Consecutive, one after another. Opposite angles are across, but consecutives are side by side. So if we're looking at those, if I have a real big angle, then I'm going to have a really small angle up here. If it comes up even to maybe even 90, now they both look 90. If the 90 gets a little bit smaller, then it gets a little bit bigger on top. So I'm starting to think real small gets real big. That if these were just two normal parallel lines and a transversal, then those would be considered consecutive interior. And I know that consecutive interior angles are supplementary. That's from a previous lesson. So the angles that are next to each other, either direction, they're always going to add up to be 180 degrees. So using all three of those now, how are we going to solve for x, for y, and then for angle z? Well, let's look at the x's. It looks like the x's are on the sides, and we're looking at values that are across from each other. We know that this is a parallelogram because the arrows support that. They tell us that we have two sets of parallel sides. If parallelogram, then opposite sides congruent. What that's telling us is that Kn is going to be congruent to Lm. So that's going to be 2x minus 3 equal to 37. Add the 3 across, so 2x equals 40 and x equals 20. So we solved for what x was, and we used this theorem to help us figure out how we could set it up. The next one, if we look at the y value, notice the y are angles, and those angles are not next to each other, but y has a relationship with 123. I don't know what it would be with two different variables, but I do have an idea with 123. Notice that they're both big angles. So that's a good reminder for me that if you have a parallelogram, then opposite angles are congruent. So in this case, we know that y is going to equal 123. There wasn't any solving for those angles. It's just written as y, and that's 123, so that's what it equals. They're congruent. But now, how do I figure out the z? I don't know what its opposite angle is. I don't have a value over there. But you could look at consecutive angles. And we've learned that consecutive angles, should be what? If you're working with a parallelogram, then consecutive interior angles are supplementary. So that's telling me that 123 plus the z is going to add up to equal 180. So z, when we subtract the 123 across, is going to come out to be 57 degrees. Now we're looking for a gate, and this looks like some sort of an accordion gate that you might hold, keep babies from walking off the edge, or keep pets in a certain area. We first need to find where angle ADC is located. ADC would be this angle. Then we need to look at what angle DAB is located at. That would be this one. So noticing that these are not opposite angles, these are consecutive angles, then I'm definitely going to say if parallelogram, then consecutive interior angles are supplementary. So that helps me set up that the measure of angle ADC, which we don't know what it is, plus the 65, which is the measure of DAB, that has to add up to equal 180. So subtract your 65, and we get 115 degrees. So our missing angle, if this one is 65, this one has to be 115. Okay, our last theorem for the day. If you're working with a parallelogram, no matter where you put it, we know that diagonals exist between the opposite vertices. What is true about those? Some people talk about how the diagonals are the same length. They're congruent. But notice that in this case you have a really short diagonal, and in this direction you have a really long diagonal. So no, diagonals are not always the same length. If you come out to be 90 degrees, they can definitely be possible for it to be the same length. But it's not always the same length. What are they doing? It's always going to be the diagonals will bisect each other. That's what the picture's here showing. That PR is cutting QS into two equal pieces, and then QS is turning PR into two equal pieces. So QM and SM, PM and RM, they're going to be congruent. So if they're bisecting each other, what is this point? That point, if you're looking at QS, that point is halfway in between. We call that the midpoint. Or for PR, it's also the midpoint of PR. So that point is the midpoint of both of those diagonals. So for our last question on the next page, we have example number 4. We're looking at parallelogram. That's what this symbol represents. The diagonals of parallelogram STUV intersect at point W. Where is this point W? What are the coordinates? Well, we could count, and that would definitely be one way to do it. But to be a little bit more mathematical, we talked about how W has to be the midpoint. Since T and V don't quite seem to hit right at a vertex, I'm going to use the fact that S is at 0, 0, and U is at 5, 6. 1, 2, 3, 4, 5, 6. Actually, it's at 6, 5. Now, if we're going to find out W, we're going to use the midpoint formula. Because W is halfway in between. It bisects the segment. That means it's at the midpoint. So this would be our x1 and y1. This is our x2 and y2. So we can plug in our numbers. 0 plus 6 divided by 2, comma 0 plus 5 divided by 2. That's going to give us 6 over 2, comma 5 over 2, which of course can be reduced to 3, comma 2.5. So over 1, 2, 3, up 1, 2, and it's halfway between. So we're right on. That would be point W.